All right, let's talk about global change. All right, so the objectives in this unit are going to be to predict future changes in the global climate, to assess current theories regarding global climate change, and to analyze environmental changes and their connection to global warming. All right, so here is just a refresher. Here's the global climate regions. So this is going to change with global warming and climate change. These regions, generally, you're going to see like this shift upwards. So you're going to get this tropical region right in here, that gray area. It's going to move upwards. This subtropical region, it's going to move upwards. You're going to get this continental, humid, temperate climate kind of turning into a moderate, humid subtropical climate. So Michigan, by 2050, is expected to be more of a tropical climate than a temperate climate. And that's just with our current predictions and current models of global warming and climate change. All right, so the global climate. The global climate is not just global warming, it's all of the worldwide statistics. So it's temperature, atmospheric pressure, humidity, wind, precipitation, other factors as well. This this is a really, really highly quantified and highly measured topic with many different variables going into it. So it is a relatively simple thing to talk about. Global warming is a relatively simple concept. With more heat, you get more energy. With more energy, you're going to get less stability, more change. But scientists have been perfecting this since the 50s. This isn't a new thing. This isn't some made up thing from 10 scientists who are trying to make money. I went out and I did climate readings. I get my name in a scientific review every year, and every year those numbers are still the same. No one is changing those numbers. So I just want you guys to realize that there's not some like Illuminati trying to mess with your brains. This is factual. This is real stuff. On the other side, those people are trying to mess with your brains. They're trying to detract from scientific evidence and push their own agenda. So you have to really be careful with where you get your information. If it's not from a scientific website or paper, then it's probably not all that legitimate. Scientific papers are great because they're peer reviewed. So that means that someone writes a paper, it goes through this process where a bunch of people get together and see if these are scientists get together and they're not the same people. They get together and they make sure that everything in that paper is scientifically valid. So there's this huge vetting process for getting a paper into the scientific community. I had to try and do it once. It didn't make it. Most scientific papers do not make the scientific journals that they're trying to make because of that peer-reviewed vetting process. So the information that you get is generally very, very reviewed, very vetted. People are looking at these things from the bottom level on up to the highest level of the scientific community to make sure that this is actual science. It's reliable stuff. So, global warming is an increase in the Earth's temperature. And I want to talk about the overall trend, okay? Because you can look at 1945 to 1970 and tell me that there was a cooling trend in that period of time. This is true, but we're going to look at the overall trend for the whole period of time since the Industrial Revolution. So, in the past 100 years, the 100-meter dash results have generally seen a trend of decline in times. So, 100 years ago, the times were a lot higher than they are now. Now, that's not saying that next year we're going to have a lower time for the 100-meter dash than the year before that. That's not what that's saying. What we're saying is there's an overall trend from 100 years ago to now of a decrease in time. So that's going to be the same exact thing that I'm talking about with global warming. Since 100 years ago, even in the last decade, we've seen this trend of a rise in temperatures. Now, every year, that doesn't mean that the next year is going to be the hottest year in record. It has been for the past 5 years, but that's just the trend. So That's what we're talking about here. And that trend of warming is going to lead to climate change. So a good example is Bear Glacier in Alaska. I was actually here. I saw this. And this was 2005. This whole area, there is nothing there anymore. There's no glacier. It's all receded. It's receded all the way back. So 1920, this whole area was a glacier, and this is most likely in a summer period as well because this lake is not iced over. So this is a hot time of the year, and this glacier is all the way up to the lake. So 2005, this glacier is pretty much gone. 2017, when I was there, it's 100% gone. There's no more glacier. So that's just an example of evidence of global warming. I mean, it's happening. Our glaciers are receding. So, with the global climate and the scientific community, we all agree that global warming is occurring. Well, not all of us, but about 90+% of the scientific community agrees that global warming is occurring, and humans are causing this warming at a higher rate than natural events. So that's the important thing, is the rate at which we are causing this warming to occur. So the burning of fossil fuels is definitely one that leads to that greenhouse effect. And then deforestation. So deforestation is really bad because the last I checked, it was the number three emitter of carbon dioxide. So the deforestation industry was emitting carbon dioxide into the air and cutting down trees, which sequester carbon dioxide and produce oxygen for us. So that's a huge double negative there. And it does not create a positive in this situation. It creates a positive feedback mechanism, if you remember that. Those are bad things. So we all agree, the majority agrees that prompt action is required. The thing that is kind of a mystery, not a mystery, but up in the air at this point is how much warming will continue to occur and how fast will this warming continue to occur. So that doesn't mean that we have time to be like, okay, well, the warming is going to stop eventually. That's not what they're looking at. They're looking at how quickly this warming is going to continue to occur and how, what kind of changes we need to make to fix that. Or at least try and, we're not going to fix it, at least try and slow the warming process down. All right, so most agree that it's going to be detrimental, that global warming process for the Earth. And even a warming in the middle range of scientific projections is going to cause significant devastation. So, like 1.5 degrees Celsius of warming on the Earth is going to be like insanely bad for our Earth and all of the systems because everything's going to try and rearrange itself and get that homeostasis. But in 10 years, the Earth can't do that. The Earth is 4.5 billion years old. So 10 years, trying to make something change that quickly, it's impossible. So really what we're doing is using a lot of technology to try and counteract that. But technology is just a Band-Aid. So we think that most benefits are going to be outweighed by the damage caused by global warming. So some benefits are going to be like increased crop time for crops to be able to grow. The only thing with that is you're going to also get an increase in pests in that same area, so you might not actually get any substantial crop growth because you're trying to compete with these pests. And not all pesticides work on all pests. And do we want to continue putting pesticides on all of our crops? So these are things that we need to think about. I personally, I would rather we just kind of try and keep a stable environment. I don't know about you guys, but it seems to be the best way to do things. So some argue that we can adapt to change from warming through technology, and this is only half true. Technology has always been a band-aid for things like this, for the ecosystem. In the long run, natural processes are always best for pretty much anything, like even your body. Taking medication might help with that certain ailment that you have, but really what that medication is doing is just helping your body to fight that illness. So the real the real preventative measure that you want to do is to continue to keep your body healthy so that your body can fight off these illnesses. So just think about it in that aspect. You don't want a doctor continuously poking and prodding you, trying to fix you. You want to just be fixed. you want to make sure that your body can handle all of this other stuff. So that's a good analogy for the Earth. Okay, and so this is kind of funny. Here are some indicators of a warming world. So less glaciers, less snow cover, the spring is going to come earlier. We're going to get less sea ice, less ice sheets, higher ocean heat content, higher sea level, higher sea surface temperatures, higher air temperatures. Tree lines are going upwards and towards the poles. Temperature on land is higher, more humidity. All of these things are happening right now. So we've hit every single one of these indicators of a warming world. We are in a warming world. And then here's just a really good graph for global temperature and carbon dioxide. There is a trend. There's a correlation here. It's a very strong correlation. In science, you don't get this nice of a correlative graph. So when we get something like this, then we can generally not assume, but say that this trend is correlative to this trend. So this CO2 line is very correlative with this increase in temperature. So here you can see this bump in CO2, there's a bump in temperature. There's a decrease in CO2 right here, it goes down, we get a decrease in temperature. And right in this area, we saw a decrease in temperature due to aerosols, and I'll talk about that a little more later on. And here, just to show you that I'm not trying to like push any agenda, this is some left-wing, very green website trying to say that we can do all of these things technologically to stop global warming. So they want to put aerosols in the stratosphere. They want to put giant reflectors in the orbit, cloud seeding. So they want to get seeds to be able to go into the clouds and precipitate down. We want some more genetically engineered crops, which that's not too horrible of a thing. They want to put some chemicals in the atmosphere to save the ozone, green the deserts, fertilize the sea with iron, and pump liquid CO2 down into the deep seas. Pretty much all of these things have no evidence behind them that they'll help. And then they also haven't thought about the tertiary or quaternary effects of this. So that's like 3 to 4 steps down the road, what this is going to do. So the aerosols in the stratosphere, this is going to cause a cooling period. And like I said, it's just a Band-Aid. Eventually, these aerosols are going to screw something up in the atmosphere. We never want to artificially put things into ecosystems. It's never going to create a stable environment unless we have hundreds and hundreds of years of evidence that this thing can actually help. So I'm not a very huge advocate of trying to change things really quickly, especially in the Earth, because that's not how things work with the Earth and with systems, with any system. A large, rapid change is hardly ever a good thing for any system. You can just think of your body. If you change things really rapidly, normally your body's going to freak out and try and fix it. So here is just a really good graph of CO2 emissions, and this is thousands of years before today, so this is for 40 million years ago. So that's where the CO2 levels were, and here's where they are now. And right here is going to be our industrial revolution when we started using fossil fuels. So you see this huge uptick very quickly. This is a crazy high rate. And then a lot of these eras, you're going to see catastrophes when this really high rate of CO2 is happening, when it's going down or it's going up really quickly. This is over 50,000 years, so that's not super quick. But this is over 100 years. It's crazy. Okay, so I'm going to stop this lecture here. I'm going to put part 2 up in about 10 minutes here, so hold tight.